Hey everybody, and welcome to TGIK, live on Friday from the Heptio Studios in downtown Seattle. How is everyone doing today? I am your host, Kris Nova, and today we're going to be talking about Weve Met in Kubernetes, which is a part of this broader CNI series that we've been doing over the past couple of weeks, where we've been looking at all the different CNI providers in Kubernetes. And we're going to talk a little bit more about Weve a little bit later. And then, of course, everybody who's joining us, we like to spend a few minutes at the beginning of the episode going over some things. We're going to talk a little bit about the Go programming language this week. And then we'll jump into actually doing some live demoing and tinkering with Weve Met, CNI, and Kubernetes. And as we all know, my favorite part of the week is saying hello to everyone who is joining us live in the YouTube chat, which you can see. How do I do this? I want to get this right. You can see it right here on the side of your screen. I think that should be right. I don't know if I did that the right way, if it's going to actually render correctly in YouTube or not, but we'll see how that looks. I can do both ways so that we know it'll work. Okay, so anyway, let's look at the YouTube chat and see what folks are saying. Okay, so I said happy Friday, and then Charles says hello. George says, hello everyone. I'll be helping Kris today with some notes. Thank you, George. It's always great to have you here helping out with notes. And we'll talk more about the notes in a second. Happy Friday from Sean Smith. We have Yar from Bristol, from Tim, Rory, evening all. George says, okay, here are the notes for the session, which has our HackMD, which feel free to click into that and follow along and add notes as needed. Olav says, good evening, fellas. Good evening, Olav, and also good evening to the ladies in the room as well, and also the gender non-binary folks as well. So Simon, hi everyone. Lamatti, happy Friday. Lamatti, it's always great to see you. Marco, good to see you again. George says, you can always find the show archives here at github.com/heptio/TGIK. PRs are, of course, accepted and welcomed. Which we can pull that repo up in a second. Let's see, Ivan says hello and happy Friday from Cheyenne, Wyoming. So funny, Ivan, Cheyenne, Wyoming is where I got my old dog, Charlie. I got him from a buffalo ranch up there, so that's the only time I've ever been to Cheyenne. I used to live in Denver, so we just drove up and picked up my dog one day. Anyway, Kazlin, good to see you, our friend here in town. Happy TGIK. Amito says, hey everyone, greetings from London. Good to see you from London. I will be in London 3 times in the next 2 months. So for folks at home in London, if you want to hang out while I'm there, I'll be doing a lot of presentations, hustling Kubernetes as per usual, and then of course eating curry in Brick Lane and petting all the wonderful British golden doodles. Greetings from Arabia. Good to see you, Waleed. What software do you guys use recording? Joe, the guy, and me, the girl, both use OBS to do recording. And in fact, I have a picture of that. I was going to show folks at home anyway. This is a question in the chat from Sin Hun. So let's go ahead and let's just pull this up now while we're here. So let's switch over to my screen. And I can go down here, and I took this picture before the episode because I wanted to show folks at home like what it looks like from our perspective in the TGIK studios, because I feel like everybody like knows this space very well, which actually is this weird empty space behind me. But I wanted people to see what it's like for me, because I'm basically standing here at this desk on a treadmill talking to myself while there's like engineers on the other side of the wall trying to work right now. So anyway, without further ado, here is a picture of the TGIK studios. It's like behind the scenes. So we do have a treadmill desk, which is really rad. And then up here on the top, we have I'll kind of go over what our setup looks like here. We have the Yeti Blue microphone, or the Blue Yeti microphone, which is like a pretty standard USB podcast microphone. That's on the desk mount, and it's got the pop filter in front of it. And you usually can't see that, but it's like right here next to my face. Up above, we have this light, which we're actually getting a sweet new light that kind of gives our skin this nice glow, so we look very beautiful while we're doing TGIK. Over here is our dock cam, and then I have been strategically like putting cute little like trinkets and doodads here on the standing up desk to kind of make me happy. So I have like crystals and like earthbound figurines and little gophers and all kinds of cute stuff. And then my kombucha and my laptop there as well. So here on the top left, you'll actually see my Twitter, and then on the top right, you'll see the OBS program that's actually streaming what is being shown in the top left monitor. And then I have this monitor on the bottom that's like my secret monitor that nobody can do anything with. So anyway, that's what TGIK looks like. Let's see what folks are saying in the chat again. Sean says he'll find out about a CFP. We have somebody else, hi from DC. I lost my spot, where did it go? Okay, Ed Sweeney says hi from Starbucks Support Center. I had some Starbucks today, good to see you, Ed. Hi everyone from Aruca, Colombia. Nice to see you, Angel. Caslin Field says you did it right. Nadir says, good evening from London, another London friend. Greetings from the forested hills of West Virginia. That sounds beautiful. Vikram, hello. Imran Khan, hi from Turkey. Fabian, hi from Berlin. Arnud, hello. Mark Van Oppen, hello from down the hall. Mark Van Oppen, hello from down the hall. If you are from down the hall and you bring me a glass of wine and or a beer today, I would not be upset. That is a subtle hint. Hint, hint. Sean says OBS. Valentine says hi from Bureaucrust. 3 seconds worse than one time is what Sin was saying. Okay, I'm going to be streaming some 3D printing this week and set up OBS for yesterday. Sean, let us know how it goes. We have our OBS, actually I can show you this, Sean, really quick. And this is for folks at home too who are interested in getting streams up and running. If you go to the TGIK repository, we have our OBS configs that we share broadly. This is the same one that Joe and I use on our MacBook, and then I have one for my Arch Linux computer, and I think Duffy had one for his Linux computer as well. We're happy to upload those, but these are handy because you can go in and actually see how we have things configured on our end, which is how we get really cool things like watch the transition here. And you can get that on your end pretty easily as well. So let's see. What other folks saying? Kamal says, finally able to watch live. Good to see you, Kamal. Darko says, what do you use for comments live on the screen? Okay, so I wonder if I can do, to show you this, for the comments live on the screen, Darko, we're going to try to do some recursive OBS here. So there's a good chance the screen is going to kind of go in on itself, but we'll just hope for the best and see how this goes. So we'll keep my face here, and I'm going to try to drag my OBS monitor into where we're capturing the screen to show you this. So let's go back to my screen and my face, and this is where, yeah, there's the recursion. Okay, so down here we have this display capture, and where is it? YouTube chat. And oh my God, that's so crazy. You can actually see it's just a media stream, and then we have some CSSs as well. We can show you how to do that if you're interested, but basically we're running a small web browser inside of our OBS stream. So enough of the recursive OBS. Let's get that out of the way. Sean says, nice, I have helped a dev advocate at Microsoft set up their OBS and tweak it to work, so I have a bit of experience. Awesome. And Lamati says, whoa, the Matrix. Okay, so that's the OBS intro that I wasn't realized we were going to do today. But yes, OBS is a rad program, and we wouldn't be able to do TGIK if it wasn't for OBS. And the small tweaks and all of the work that Joe has put into it and that I've come in and helped with the repo and publishing it. So yeah, it's really cool, and it's fun. It's kind of nice to have this all set up and dialed in this really sweet studio here. Okay, so let's go back to our HackMD here. George has a pro tip for folks at home. Pro tip, enable hardware encoding in OBS settings that will use your chips encoder instead of melting your laptop using a software encoder. Yes, 100% pro tip there. We definitely have that in our OBS config, I want to say. Let's see if it's in here. Stream encoder.json. Nope. Recording encoder? Nope. Somewhere in here we have like a hardware encoder kind of thing. I don't know. Anyway, we have that bit checked somewhere along the line in one of these JSON files, but it does help out quite a bit. And also getting the bit rate just right in YouTube is quite important as well. And YouTube has this really cool feature that will let you know if your stream is like good or just okay, or if it's kind of bad or not working at all. And we try to usually keep TGIK around good. Jim Angel says fire because of the hot laptop. Makes sense. Okay, let's talk about Kubernetes. That's why we're all here. Well, actually, let's talk about Go and other things that happened in Kubernetes this week. Then let's talk about Weve on Kubernetes. So we do this every week. We have like a little markdown file. And this week, we're going to do a week in review, and we're going to talk about these things. So this is kind of cool. We've been doing it where I'm kind of blind to these. In the past, I was the one picking these out, and now George has been helping out with these. So it's like I get a new one, and I get to kind of read it live on the air every time, which is exciting. Announcing HashiCorp console plus Kubernetes. Now, I know folks have done this in the past, but is this like a more like formalized console Netties thing? Where is this? It's on the HashiCorp blog, so I bet that's implying that HashiCorp has done something to make this official. Let's see, features. The following is a list of features that will be announced and released in the coming weeks. Following an announcement blog post, we'll cover each in detail. But it looks like HashiCorp is going to be publishing a Helm chart for console for you to run console in Kubernetes. There's going to be some auto join features, and it looks like there's going to be some service catalog stuff. I am not going to make a comment. Just kidding. But this looks really exciting. I have been waiting for something official like this for a while. I think there's already a console Helm chart. Let's go, what is it, GitHub. Let's go see .com/Kubernetes/charts. And then I bet in stable or the incubator, I bet there's already a console one, but let's see. Yeah. So I'm wondering the differences between what HashiCorp has put together and this chart here. And of course, wondering what the backend implementation and actually what we're deploying looks like. So I'll make sure to check that out as soon as we can find an actual example of the Helm chart. That's really rad. Also, hats off to HashiCorp for helping us out with Kubernetes. And I think my beer is here from Mark, so let me go grab Mark and my beer really quick. Yay, thank you.
You get a ginger ale, not a beer.
What? No, hold on. No, that's not even fair. Now you're just teasing me. He gave me, it's like I'm 10. He gave me a ginger ale instead of a beer. Just what I need, more sugar, clearly. Well, Maddie says, this looks interesting. Do you see this being a replacement for the built-in service discovery in K8s? I don't know if we'll see it as a replacement, maybe more of like a complementary piece along the way. A lot of the HashiCorp products are a little more battle-tested, and getting those into Kubernetes would actually be a big win, specifically for people who already have tooling that talks to them. So I think this is just another really great example of getting more DevOps-y style tools built into Kubernetes that's going to make the Kubernetes ecosystem more rich and more complete and easier for folks to adopt, which 3 million thumbs up there. George says, exists and appears to be maintained. Josh says, ginger beer. I actually think I'm going to drink this kombucha here, which actually probably has more alcohol content than the beer that Mark brought me. Anyway, let's go back and see what's next. So we have BlueGreen node deployment Kubernetes EKS Terraform. What is this now? Here at Lumo, we're using Kubernetes. Excuse me. We're using Kubernetes for our API, supporting services and auxiliary cron jobs for our data pipeline. Before EKS was a thing, we deployed our clusters using KubeSpray and Terraform. Okay, so what is this going on? What is going on here? Check your load balancers, drain the old nodes, transition pods slowly. Okay, so this just looks like it is, oh, they're using Heptio Arc. It looks like it's a new way of managing nodes that are configured to work with EKS using Terraform. And this looks like it's a pretty solid write-up on how to manage the load balancers. Looks like you can drain your old nodes, which makes me think that there's some sort of upgrade story here. Scale down the old auto-scaling group so we can actually use the Amazon API to manage our ASG, which is handy. And it looks like, I'm going to read what this says. API latency is slightly higher than our KubeSpray deployments, but that expected to give out how API traffic now transits. EKS, with the help of Heptio Arc, also has cut our Kubernetes cluster deployments from under 1.5 hours to 20 minutes. So that's really rad. So this looks like a pretty complete write-up of how these folks are approaching managing and mutating EKS clusters with Terraform, which is pretty sweet because this is something that we've been talking about a lot in upstream Kubernetes as we're looking at building out the AWS Cluster API implementer. We just recently decided on the vernacular to use to describe the different avenues in which one would manage nodes. The word we picked was variant. So this is a really great example of a potential cluster API variant if we could have tooling like this, or even this tooling concretely, respect and speak the cluster API, which hopefully will be our CRD very soon. So slowly getting the community together and making this stuff more of a standard. So that's really exciting. Mark says, you're welcome for the ginger beer. Thanks, Mark. I'm going to, I'll drink it here on the air, but I think it's, oh, is it a twist off? Yeah, it is. Okay, so here, cheers, Mark. Thank you so much. It's actually pretty good. I'm not going to lie. It's actually really good ginger ale. Okay. So let's go back and look at Weve Met. We have dynamic database credentials with Vault and Kubernetes. Let's see what's going on here. How we at USwitch managed to get all of our applications to use short-lived database credentials without changing their code. Almost. Great intro sentence. Nicely done. Static database creds tend to slowly accumulate and get spread around in most organizations over time. Okay, cool. So this is actually using another HashiCorp tool, Vault, as a credentials store in Kubernetes, and then actually using that to store secrets for your database. This is pretty rad. I know people have been tinkering and playing with Vault and Kubernetes for, like, I think almost 2 years now. So getting to see concrete examples of this are always exciting, and getting to see how we're using it for database creds is a really great example. So this looks like a good write-up if you want to go learn more about running Vault on Kubernetes and how that they have used it for database secrets along the way. Thanks for the share there. Kubernetes operator deployment guidelines and an improved usability. Let's see what we have here. Kubernetes Operators extends the K8s API to manage third-party software as native Kubernetes objects. Yes, we all know what a Kubernetes object is. Let's keep scrolling. Okay, so this looks like it's just a write-up of what a Kubernetes operator is and how one would use it. And there's some guidelines here that they put together to sort of explain what an operator is and how you should be implementing it. Okay, and the guidelines are prefer declarative state over imperative actions and custom resource spec definition, which good, we all want to be state-driven, and we want to be declarative in nature. That's like the Kubernetes, what's the word I'm trying to think of? Idiomatic Kubernetes is what I'm trying to say. Use owner references with CRDs, or custom resource instances. Generate an open API spec for your custom resources. This is a great one. If you do generate an open API spec, you can implement it in many other ways, and it makes publishing documentation a lot easier as well. So I would totally agree that if you're going to write a CRD, you're going to write an operator, you might as well write an open API spec so that we can use it for all the other goodies as well. This is a great guideline here. Package operator as a Helm chart. Strong disagree there. I think speaking Kubernetes primitive is probably a more universal form. And then if you want to take those static manifests and then also put them in a Helm chart, I think that's a good idea. So I would word that a little bit differently on my end. Use Helm chart or config map for operator configurables. Again, I think this is a great idea. Helm does a great job at letting you configure various parts of Kubernetes manifests, as do config maps, but having some sort of configuration there is a good idea. Use config map in annotation or spec definition for CRD configurables. I'm going to go through all of these because these are like really interesting. Plus one here, I totally agree. Annotations and config maps can be confusing for folks, so having a clear understanding of the differences would be helpful. And I think in various cases, using one over the other makes a little bit of sense. Define composition of a custom resource as an annotation in its YAML definition. That seems, I'm curious why they want to do that. By servicing the composition information as an annotation on the CRD, it is possible to build tools like Kube Discovery. Okay, so other tools expect that to be there. That makes sense. Plan for custom resource metrics, and plan to use Kubectl as the primary interaction point. Plus one, strong agree here. Great guidelines. Actually, I'm going to share those guidelines with the Cluster API folks because we're looking at building out some operators and controllers right now anyway. So there's some good stuff there. Looks like we have Agones? I don't know how to pronounce this. Version 0.4, congratulations to the team. And it looks like if you want to check it out, you can come to the release tag here. So hats off to them. K8s 1.12 is in beta already. And etcd recommended new versions. Sean Smith says, yeah, he's going to have to read up on those guidelines. Yeah, I would say read up on them and, take them as like a suggestion. And, it doesn't have to be like the bespoke way of doing something, but there's some good stuff in there, Sean. I would check them out. Okay, so this is recommended etcd minimum versions. And this is on the discusskubernetes.io that our friends in SIG-contrib-X have been working hard on. So I love this thing. I think it's great. And if you, in the past, we've done like a live update on one of these when we logged in with GitHub, but this is just basically like a new source that serves as documentation as well. So this was a really brilliant move from our friends in SIG-contrib-X, and here's a really great post talking about the minimum etcd versions you should use. And it looks like it was created by Brandon Phillips from CoreOS, now part of Red Hat, who was one of the, I think, original authors of etcd, so there's probably some pretty good stuff in here. Come check that out if you're interested. Okay. We're already 22 minutes into the episode. I feel like I'm rushing, but I think we spent a lot of time talking about OBS at the beginning of the episode. And so before we get into Weve, which I know that's why we're all here, in the past I've been doing little Golang sort of like tips, tricks, exercises. Did you know this? Did you not know that kind of thing? And I put one together for this week. And the reason I put it together is I just recently at GopherCon got to have the errors are values discussion with a couple of newer Gophers. And I remember that was one of the first blog posts I ever read about Go that Rob Pike wrote in the long, long ago. And this is 2015. This is a fantastic write-up. It's, like I said, one of the first things I read about Go, and I think I just enjoyed Pike's literature so much I continued to research the programming language more, and then ultimately fell in love, and poof, here I am. Anyway, we're going to be talking a little bit about the error interface today and showing folks how to build custom errors in Go and talk about when you might want to use them. So we'll try to get this done in the next 5 to 8 minutes. I bet we can do 5 minutes. Let's try to do 5 minutes. So how we're going to do this is we're going to open up this really rad thing that we have looked at in the past called goplay.space. And I will be typing this Go source code literally, so forgive any compile errors, but I'm going to do my best to get a hole in one. We'll see how I do. Okay, so first things first, we want to understand what the errors interface is. And so we can do that here by defining a new variable that we will call custom error. And we will set that of type error. And goplay.space allows us to click on types that if they're defined in the standard library, let's see if this works. I guess it doesn't work right now. There we go. If they're defined in the standard library, it'll look it up for us and tell us what it is. And you can see here on the right, the error interface is actually one of the simplest interfaces in the standard library. It just says you need a publicly accessible method called error that returns a string. So we can implement a custom error by saying a new type. We'll call it TGIK error. Say it's a struct. We're not going to define anything here for now, so we'll say that's empty. And we'll make a method in Go. And how we do that is we define a new func. We give it the, we'll say TGIK error, referencing the struct we just created, TGIK error. And here's where we actually implement this interface over here on the right, and we say we want error, and it returns a string. And then here we would just return some string. In the fancy Go path, Sen says maybe do the Go module package version control next time. I found that probably the most immature part of Go in the fancy Go path. Sean says, yes, I love writing custom error types to make my life easier for determining status codes for my HTTP status responses. Sean, you stole my example. I was totally going to use HTTP here today. But yeah, we'll talk about that here in just a minute or two. Happy to know I'm not the only one who thinks that way. Okay, so we actually want to have a value here. Remember, the whole point of the blog was errors are values. So we're going to create this new field in our struct. I'm trying to use proper Go vernacular here. And we're going to call it the error value. And we're going to make that a string. And all the error method does is it returns a string. So how we're going to do that is we're just going to return the error value itself. Okay. So now let's actually create a convenience function for us that's going to help us initialize a new error. So how we're going to do that is we're actually going to make this unexported, and we're going to say func new TGIK error, and you pass in some message of type string, and you're going to get back a error interface implementation. And what this is going to do is it's going to do return a pointer to TGIK error, and then in here we're going to do error value is equal to message, and that should be of type error because TGIK error has the error method on it. And down here, we can actually have a function that says function HTTP things, and then that can return an optional type error. And the reason that we do a pointer here is so that we can nil it later. A lot of times in Go, you'll see the idiomatic way is to do if error not equal nil. The reason we can do nil is because it's a pointer, so we can actually assert if it's a nil pointer or not. If we didn't do a pointer, we wouldn't be able to do if error equal nil. It's just an exciting part of the Go programming language there. So we can come in and we can get rid of this custom error. We'll keep our from to print line just for good measure. And we will do an HTTP things call. Hello from TGIK. And down here we will call HTTP things. And we will do error is equal to this. And if error not equal nil, fumt print line, we'll just print it out, why not? Error dot error. Somebody said something is misspelled. Error value is misspelled. Error val, thank you. Value is misspelled. Okay, so, and then here we can do error is equal to new TGIK error. Oh no, something went wrong. And we can just return error. We could have just done a return there. So let's see what happens here. Let's run this. Is it not running? Nope, I did not get a hole in one. TGIK error has no field error value, but does have error value. There's, dang it. Capital E that I changed. I was so close. Okay, let's see here. It says, hello from TGIK. Oh no, something went wrong. Okay, so here's a really great implementation of a custom error message. And what's cool now is, as a software engineer, we can now do anything we want with this struct, and we can have it populate any value here, and we can even put other methods on it as well. So to use Sean's example, we could have TGIK error. We could have it return an arbitrary status code if we were doing HTTP something or other. And let's have that return a string. Actually, let's have that return, a string for good measure. And here we could do, we know that this HTTP things is going to return a specific error type, or we could do a type assertion. And we could actually do fumt, let's do it here, fumt print line error dot, we're going to marshal or type assert this, typecast, oh my god, into TGIK error, and then we're going to be able to call status code on that. And also, let's just, for now, we're just going to bypass this, and we're going to return, let's say 200 okay. Everything's fine. Okay, so now we got a 200 okay. So you can see here, and we could actually put this typecast into an if statement so we can actually check and see what type of errors are defined. And as a software engineer, you can create all cool sort of fancy error handling methods to do whatever you want, and you can pass really cool values around and make your program respect those values. So creating custom errors is very similar to creating like a custom exception in like the object-oriented programming languages like Java. And we can now do stuff like that in Go. So that's your Golang tip of the day, and I did it in 5 minutes like I said I was going to do. Okay, so let's talk about Weve in Kubernetes. So if you go to the TGIK repository, I have already pushed up this new directory called 50, which if we print working directory, you can see here we are. Imran Bhatti says, I tried to send another Rob Peck's post, but error, but can't send an address. Is it okay to put it in HackMD? Yes, 100%. Please add it to the HackMD. We know we can't send links here in the YouTube chat, which is why we have the HackMD. So this is a great example of what to do here. So Sean says, that's not normally how I do it. I generally switch on the type and then based on the type do something. But that's a good way to do that. I'll probably start doing. Yeah, I usually do a type switch too if I know that my program has a lot of different custom errors. And I'll probably have one monolithic type switch at the very beginning of my program, very close to the main function somewhere. And then I can put all of my custom error handling in there with different exit codes. Like maybe we want to exit 2 if we get an error of this type and exit 3 if we get an error of that type. That's particularly useful, especially when running in Kubernetes, because you can capture the exit code, and that usually gives you a clue into what's going on with your program and why it might have crashed or broken and why the scheduler is rescheduling it. So yeah, errors in Go, they're really bad. So back to our terminal here. We are in directory 050 in the episodes directory in the TGIK repo. And then in here, this is like the fourth time we've actually done a Kubicorn cluster for CNI. So this is like pretty familiar for folks if you've seen any of the other CNI episodes. Here we have a custom shell script, which we can look at that by catting that out. And you can actually see down here, we just do a kubadmin config, and then we apply the storage class for Amazon, and we do not install CNI. Usually right here in the Kubicorn bootstrap script, you would see us doing some sort of CNI install, and we simply removed that line from the default Kubicorn bash script, and now we're going to deploy a cluster using this bash script, so no CNI will get installed. So how we do that is we can cat out our README, and we should have these two commands here. So here's the first command, which will create our state file for our CNI list cluster. So we can do this. And it says the state Kubicorn TGIK Weve cluster.yaml was created. And then you can run this command here, Kubicorn apply. And then we also have to pass in our state store, which is just this directory called Kubicorn here in the 50 directory in TGIK episodes. So if we run that, we're going to create a cluster in Amazon. So we can jump over into our Amazon configuration here. And sorry, somebody was just texting me. Jump into Amazon and see what's going on. And as always, I'm going to close a bunch of these that we've already looked at. And then I'm going to put the errors or values, unless it's already here. Somebody tell me if the errors or values already made it into. I don't think it has. Okay, so I'm going to add it under show notes, go tip of the week. There, errors or values. And if we go into Amazon, let's look at our instances. You can see I had a Weve cluster already up and running that I have since terminated, and now we're bringing up a master and our node is well on its way. So let's go to iTerm, and it says hang while fetching kubeconfig. So our cluster is coming up. So real quick, while we're waiting for our cluster to come up, which should only take about another 30 to 45 seconds here, do folks have anything that in particular they wanted to learn about with Weve Met today? My plan on the fly was to do the side-by-side comparison that we've done with all the CNI, where we look at network policy, the CNI plugin, how the daemon set works, how it's installed, and then talk about the software layer of how it's actually building the pod network and how it's different than the others. Weve is very unique in that sense. It does a lot of things that none of the other CNI providers do. So we'll talk a little bit about that, and then we're going to look at the Weve command line tool and look at this peer list that Raphael, a friend of ours, I think Raphael lives over in Germany, although he might have moved, I don't know. Anyway, so he may or may not be on the show today, and he asked us to do a little bit of detective work there, so we're going to make it a point to check it out. So Sin says, how is the network policy implemented? Okay, we can definitely talk about the network policy. And it looks like our cluster's up and running. I do love Kubicorn. Like, I'm sorry, every time I deploy it and it's like pretty colors and I get this happy green thing at the end, it like just makes me really happy inside. Sin says, does it really need to be privileged or net admin capabilities will be sufficient? Not sure I understand your question, Sin. If you maybe could try rewording it or, yeah, just try rewording it and see if I can understand it a little bit better then. I'm not really sure what it means in this context. Let's jump onto our node. That kombucha was really powerful. So how we want to jump into our node is we're going to SSH into this ID. So SSH Ubuntu at this. Yes, and we'll sudo up. And then we're going to open up another tab. We're going to zoom in and resize. That looks good. And let's do a quick kget nodes. And of course, because we don't have CNI installed, we get this not ready. And Sean says, yes, the flower at the end of Kubicorn is a great touch. It's almost as great of a touch as if you do export cubicorn true color equal to 1, and then run cubicorn, you actually get a rainbow unicorn, which is by far the best part of the program. So anyway, here we can kget nodes. We can tell that they're not ready if we do our infamous kdump command, which remember, kdump is the same as doing kubectl get all -- all namespaces, which just lists everything in Kubernetes. We can see what we have running in our Kubernetes cluster. So you can see we have etcd, API server, controller manager, kubedns, kubeproxy, all the goodies, the scheduler that we're used to seeing for the control plane. No CNI running in kubesystem. And if you look, where is it? Here, kubedns is pending. Anybody who's ever worked on installing Kubernetes knows that if kubedns is pending, that's probably the biggest red flag that we need CNI something, or CNI might be gone. David says OMG, so I'm assuming that OMG is in response to the rainbow unicorn, in which case, thank you, I very much agree. It is overwhelmingly beautiful. Okay, so CNI is not installed. We're SSH into the node. We're going to do our good old journal cuddle command. So root, let's clear our screen. And I feel like everybody at the same time, the whole class, journal cuddle, FU, kubelet. Okay. Oh, did I spell it wrong? Dang it. Journal cuddle, FU, kubelet. Okay, and then of course in our journal cuddle FU kubelet logs, we're seeing that CNI is not ready. So let's go ahead and let's install Weve. So how we do that is, let's go back to Google Chrome here. And I have this section here that has all of the links that we need. Install Weve in Kubernetes, or Kubernetes, as Liz would say. So there's this kubectl apply. And real quick, before we run this kubectl apply, because we're going to want to look and see what the daemon set is doing, and we're going to look at the YAML and do all that fun stuff anyway. I'm going to give you guys a little bit of a backstory and tell you an interesting piece of trivia about this kubectl apply command. So yesterday morning about 8 a.m., I jumped on the phone with Brian, one of the network engineers over at Weve, who gave me like a personalized deep dive into Weve and talked to me a lot about how it implements IPsec and does encapsulation and all this other stuff we're going to get into a little bit later. While I was on the phone with him, he had mentioned that he thinks he was the first person to actually do the kubectl apply for CNI. And I vaguely remember years ago when I was working on COPS and we were first implementing the CNI networking stuff, this definitely was the easiest one to implement because it already had the kubectl apply written out for us. So as far as my memory serves, that statement is actually true, in which case, hats off to Weve for giving us the equivalent of pipe to sudo bash for CNI and Kubernetes. And without further ado, we're going to run the infamous Weve Oneliner here and get Weve up installed. So let's do that from my local, which is in this tab here. And we'll clear our screen, and we're going to do kubectl apply. And then what's going on here, actually, let's not do a kubectl apply. Let's do a curl. And we can actually see what's going on here. So, curl, and then we hit HTTPS, weworks, Kdesnet, Kdes version, and then we just run this kubectl version, pipe it to base 64, and then this removes white space and gets rid of new lines. And then that's going to give us our Kdes version, which is going to help complete the URL, and that's how we're going to get whichever version we need, which is cool because then it'll automatically populate based on whatever version of Kubernetes we're running. Aha! So let's look at some YAML here in my terminal. I'm trying to do this whole episode without opening up my text editor and just doing everything in my terminal. Text editor also including Emacs, so we'll see how far I can go. Okay, so this is interesting. You don't see this every day. We actually have a proper list defined, a list proper. And in the list, we have a list of other Kubernetes objects as well. So the first item in our list is this service account. So already we know that Weve is being installed using RBAC, which is great because we're running in kubesystem, so we very much want to make sure that we're only using the resources we need and we only are able to talk to the resources we need to talk to, and everything else should be shut down. So hats off to Weve for getting RBAC up installed. And if you come in here, it's pretty straightforward. They create the service account, then they create the cluster role, which is called Weve Met. They're defining access to pods names, or namespaces in nodes. They can get list and watch, which is pretty much read only, which is handy. And we have a cluster role binding that binds the two together. So great RBAC implementation. Oh, and then we actually define a proper RBAC role as well called Weve Met. And it looks like that one can get an update, so also read only as well. Sean Smith, I didn't even know kind list was a thing. That's good to know. Yeah, kind list is kind of nice because then it creates, like here. Oh, I haven't installed it yet. I think you can kget list and actually like pull a list of all your resources, which is good because it kind of acts as a logical grouping for things in Kubernetes, which is handy. So let's go back to our YAML here. So we just kind of gave a real quick overview of the RBAC. That looks very legit. Everything looks read only, so it looks good to me. We already looked at the role binding. Aha, the infamous CNI daemon set. So let's see what Weve is doing with their daemon set. So we have an original request URL, an email address, support@weve.works. We're installing into kube system. We're giving it the Weve Net name label. We're creating multiple containers. The first one is Weve, and it runs this Weve launch shell script, which we can find in the repo if we want. And we're pulling this docker.io weaveworks Weve Cube, which is the, this is confusing. Weve Cube is the name of the Weve Net image that is going to run the Weve CNI plugin. So they're all kind of the same thing, but different names along the way. And it looks like we're running 2.4.0. We do have a liveliness probe on status 6784. And we have some volume mounts here defined. And then this next one, this is our another container called Weve NPC. We defined a handful of environmental variables, and in this one, we pull this other image called Weve NPC, also version 2.4. Doesn't look like we're defining any liveliness probes or readiness probes, which might be helpful. But we do have a handful of volume mounts, and it's mapping it to our service account WeveNet that we created above. Okay, so that's probably why we had the role and the cluster role above as well. And then what program are we running inside of this thing? I don't see command anywhere, do you? I do not. Okay, well, we're going to run the Weve NPC container as is then. Okay, cool. So we can now... Oh, looks like Justin has a comment, and so does Sean. Let me read those really quick before I do my next move here. Sean says, cool, I normally just define multiple YAMLs in the same file, separating them with .. And Justin says, if you kubectl get pods OYAML or whatever resources, it will give you a list as well, which is very true. You'll get a list if you do anything OYAML on a group or a list of things. Rory McCoon says, as a security type, shame it runs as privileged. Yes, Rory, good call for pointing that out. Unsure why it needs to run as privileged, but I have a feeling this is what Sin was asking about earlier. Let's see what Sin says. Is the container needs to be run as privileged container. If we just use the net admin capabilities, is the security context for the pod would be sufficient? Sen is a great question, and for right now it is defined as privileged, although I am wondering if we broke Weve apart and compartmentalized it, if we could bypass the need to run privilege as well. I can look into that and talk to our friends at Weve and see what they have to say about that. I'm imagining running as privilege is going to be a concern for most folks. So good call on pointing that out. Thank you, Sin, and thank you, Rory. So let's run our install command and look and see what the daemon set's doing. And I guess before that, we can stop our journal Cuddle FU kubelet, and we can go to Etsy, CNI, which does not exist yet. And now let's go run our daemon set here. So we're going to do that by changing curl to kubectl apply -f. So there's our service account, cluster role binding, role, and role binding, and the daemon set. So let's go and let's see what's going on in our cluster now. So we can do a Kdump. Okay, cool. So now you can see that this is still pending, but we at least have our WeveNet daemon set, and then you can see the Weve pods are coming up and starting to do their magic on the underlying node. And I bet if we list this, we do have our CNI net.d directory, which means CNI is installed. And I bet if we do our journal Cuddle FU kubelet, we can actually see, yes, that the CNI is up and running. So that seems to work as expected. Let's see what I want to do now. Let's talk about how Weve manages itself on nodes for a bit. I think that's a good starting point. So Weve uses a protocol called Gossip. So let's see if we can find some documentation on this for folks at home. Weve, Gossip, Gossip DNS, which is how they sort of find peers. So if we look at other CNI that we looked at in the past, the first one we looked at was Cilium. And if you remember the first few minutes of the Cilium episode, we talked about how important it was to get etcd either A, configured properly, or B, set up and running external to the already existing etcd, because the CNI implementation actually had a data store proper that it would store things in. We saw the same pattern with Calico, where you could optionally install your own etcd or use a different etcd as well. And remember, we learned from Flannel that it used the existing Kubernetes data store whenever possible, which was a sort of elegant solution. In this case, Weve does not need a data store at all. Instead of needing a data store, what Weve does is it sort of has this in-memory data store and uses Gossip to like share information between the various peers in the network. And because of that, like, we're sort of introducing a little bit of a risk, but we're also introducing this really cool feature, which is a lack of dependency on a data store. So one of the exciting features here that could also be a little bit scary if you aren't aware of it, just because it behaves differently than the other CNI providers, is that Weve will be able to be compartmentalized and re-catch back up. So it's this whole concept of being eventually consistent. So let's talk about what that means. So I'm going to draw a quick diagram with the sweet doc cam. Oh, you guys can see my ginger ale. It looks like I'm just like totally pounding a beer right now. So if we had 3 nodes in a network, and we'll draw this other one down here, and we'll say this is node 1, this is node 2, and this is node 3. And we installed the Weve daemon set, and all of these nodes were running in Kubernetes. What's interesting is that there would be a piece of software in each one of these nodes that's running as a pod that would do Gossip to find the other ones and start to share information about what's going on there. And we're going to look at actually listing the peer list that Weve discovers here in a little bit. And what I wanted to point out is if for some reason we lost connectivity and this part of our network was isolated, meaning that this node was taken offline, maybe a network cable was cut, something was going on, this node would actually still be able to function. Now, this is exciting behavior because everything within the concept of node 3, if it was still online, let's say that there was another network, and this could still reach out to the, we're going to draw our internet bubble here. If all of these could still reach out to the internet, then our cluster for the first few moments would effectively be fine regardless of this compartmentalization here. What's cool, though, is if all of a sudden we poked a hole in this network partition, for lack of a better term, or like let's say we re-terminated the cable and plugged it back in, this pod on this node would ultimately catch back up and resync with the rest of the cluster. Exciting because it gives us a little bit of resiliency there. Also scary if for some reason this goes out of whack and these two move ahead, and then this one doesn't know what's going on, and then there's some sort of delta between the two and causing unknown problems in your cluster downstream. So there's pros and cons to each. If you're running in a data center, information like this is going to be really valuable because you're going to want to know what's going to happen to one of these machines if some sort of unknown network catastrophe happens along the way. And depending on what you and your team want, this may or may not be desired behavior, but just wanted to point that out as well. And Weve is totally doing all of this at runtime and syncing with itself at runtime. So we can look at that by SSHing into our node, which we've done here, and we can pull this really cool Weve command. Actually, before we do that, I want to just demonstrate that CNI is working, and we can talk about the peer list that I just described a little bit, and then let's talk about the overlay network and network encapsulation as well with Weve. Okay, so let's install our Nginx pod that we do in every one of our CNI episodes here. So we'll do our krun Nginx -- image Nginx. Seriously, I like cannot do TGIK without creating an Nginx pod, I swear. Okay, so that's up and running. We'll do our Kdump, and we should be able to see that our Nginx pod running in the default namespace. Oh, it's creating right now. Let's run it again. Our Nginx pod running in the default namespace is up and running. So CNI appears to be working good for all intents and purposes. Justin, looks like Justin had a question in chat. Does netadmin allow for mutating the IP tables of the host machine? Calico requests a similar set of capabilities. That's a really great question, Justin. Oh, sorry. Switch back to your desktop. Thanks, folks at home. Obviously, this ginger beer is getting to me. So let's do this. Let's go back to my screen in my face. And all I did here is run kubectl run nginx -- image nginx, which is here. And then after that, I listed, container was creating, and then I listed again, and our container's up and running. So we should be back to speed here. Thanks for letting me know. Friday at 2 o'clock in the afternoon. Like it's been a long week. Drinks more sugar because clearly I need that. Okay, so anyway, Nginx is up and running. CNI looks good. Weve seems to be weaving. Now let's go and let's jump on the node and actually see what Weve is doing. So we can come back on our node, and here in our documentation, we have this install Weve CLI tool on the node. So Weve comes with this handy dandy bash script that you can get here. And then all you have to do is just add it to your path and chmod it to executable. And it's we'll actually look and see what this thing does here in a moment. I've already looked at it, so I'm just going to go ahead and grab it. But folks at home, you probably want to go and actually curl this before you actually move it into your path and make it executable. So we're going to curl it down, and we're going to chmod +x user local bin Weve. And we can actually cat user local bin Weve, and we can actually see what's going on here. So it's a very long, very beautiful bash script, which I do love. That, oh my gosh, this thing goes quite a ways up. That does a lot of magic behind the, oh my god, this thing is huge. It actually overflowed my buffer. Let's look in GitHub at this bash script. So github.com/weaveworks/Weve. And then down here in the repo, we have this Weve file, which this is what we just curled down and made executable. How many lines is this? Oh my goodness. Oh, I love when bash files are longer than 1,000 lines. Okay, so I don't think we're going to have time to go through this whole file in detail today, but I just wanted to show folks that the tool we're going to be running, the source code is here, and you can actually go in and see that this is actually a proper command line tool with different various subcommands and different flags, and it looks like there's a big switch here at the beginning that allows a lot of cool stuff to happen. And then I bet if we came down here, we can actually see, are we curling anywhere? Yes. So we actually do a lot of curling on various endpoints here locally, and we're going to kind of look at what that looks like on the node here in a second in this HTTP call bash function defined here. So to get back into our node where Weve is now executable, we can just run Weve, and it's going to pull this container, and it sort of spits out this help command in this bash file that we were just looking at here. So scrolling on up, we have Weve launch, we have Weve prime, not to be confused with Amazon Prime. We have Weve env, connect, attach, expose. Looks like there's a lot of cool, exciting stuff you can do here that would be useful for you and your engineering team to come and debug CNI. Which I guess, speaking of engineering team, that was one of the first things that Brian had mentioned. Hey Duffy, good to see you. That Brian had mentioned when I spoke with him was this tool is very much defined, like was built with the engineer in mind. So this whole CNI implementation here is sort of like a for engineers by engineers CNI tool that you are welcome to use if you so choose to. And it's designed to be ran anywhere. So it doesn't really matter if it's Amazon or Azure in your local data center. And it's supposed to be sort of handy and give you a lot of tooling, which we're kind of looking at here, to make it easy to debug your systems and understand what's going on in your systems. So this is a very engineering-centric tool. It looks like other folks are saying hey to Duffy. George says, and I'm out for the weekend. Thanks, everyone. George, we'll see you next week. Thank you for all your help that you always do. And the first thing that I want to look up is Weve status, I think, right? Is that in here? I don't see, yeah, right here, Weve status. So let's do a quick Weve status, and we can see what's going on. And how this actually worked is Weve listens. There's a server running locally on our node here. Let's see if I can find this thing. So I think I can do netstat tulpen. And you can see here we have something listening on port 6784, it looks like. So let's see what happens if I hit that port. Curl loopback on 67. I think this is the right port. Let's see. 404 page not found. Okay, so there is a server. There's something listening there, which is exciting because now we can understand how this command line tool that's running in a container that's really a bash script is actually interacting with the rest of the Weve system. So that's sort of how the rest of our tools can come in and interact with the system. I am curious if the server is running with auth and encryption. It doesn't look like it's using TLS, which I guess it doesn't necessarily need to, but I'm wondering if it authenticates in any way. The last thing we would want is we would not want erroneous pods on the same node to be able to curl localhost on the node and actually interact with the server and possibly make any mutations to the underlying CNI implementation. So that's a follow-up question for me as well, which is how is this API server being authenticated, if at all? And again, we can look into that and get back in the YouTube chat comments later. Okay, so the next thing I wanted to do, and I actually have a doc on this. I might pull this up really quick. Give me a second. I know I'm off screen. Just bear with me. Does anybody have any good jokes while I pull up my notes here? We need some elevator music. I wrote down a lot of these commands. I wanted to pull them up. Okay, cool. So yeah, we did Weve status, which gave us an overview of the Weve software layer, Weve Met that's running. It talks about this range and this default subnet. So I guess now would be a good time to talk about how subnetting and IP allocation or IPAM works with Weve. So one of the things that Weve does is it dynamically allocates IP addresses based on the nodes in the system, and that can change. In other CNI implementations, you'll notice that a lot of the IPAM management is static, and that as you create more nodes, you run into this problem of how much address space can you give each node, and then after you statically assign some address space to a node, it makes it harder to divide that space for other nodes as they come and go. So Weve dynamically does all this for us so that we can arbitrarily add and drop nodes without really worrying too terribly much about how our IP address space is being allocated. Furthermore, it's important to understand that this IP address scheme is for our overlay network. So if you look here on the node, and this is where we're going to kind of talk a little bit about overlay networks, which we see in other tools like CNI and Cilium, and why they're relevant to Kubernetes and how the encapsulation is done. So if we actually do an if config on the node, you will see that this IP address is 10.0.100.125. So this is the node network. Up here, we have this 1032 block, and it's a /12, so it's enormous. And this is actually what the overlay network is that Weve is going to be using for our various pods. So all of the pods are going to be assigned an IP address in this network, and then those IP packets are going to be sort of buried or encapsulated inside of broader IP packets that are being transmitted around on this network here. So if you follow me on Twitter, you noticed one of the comments that came out of my discussion with Brian was giving us a quick understanding of network encapsulation and said something super funny, which was, actually, I want to read this because I don't even really remember exactly what he said. But it was, no, not Wunderlist. I want to go to Twitter. Twitter.com, which was, I don't know why it's not pulling up my Twitter. See if I can find it. I might not be able to find it off the top of my head. Anyway, it was basically network encapsulation is a way for network engineers to bypass, or for engineers to bypass talking to the network folks, which I thought was very funny. Because we're creating our own network and using the broader network to sort of hide our network inside of. Okay, so let's go back to my terminal here. enough about overlaid networks. Let's look at the peer list that Weve is creating for us, and then let's create a node in Kubernetes and see what Weve does behind the scenes. So we can do Weve status peers, and this is exciting because we're actually seeing quite a bit of information here. The first thing that we're seeing is what looks like a MAC address, and this is actually the MAC address for the bridge that we're creating on the node system. Then inside we have the host name of the system, which if you look, this is will match this, but we're running in a weird EC2 region, so they're not a one-to-one map. And then below we have sort of this like textual representation of how we're managing our network down here, which basically says that we're just forwarding traffic over to this other address as needed. And if we look, it's coming back from ourselves here. So because we have two nodes, we have to have a rule for outgoing and a rule for ingoing. And then when we add a new node to the Kubernetes cluster, we can see how this is going to change. Let's see what folks are saying. Sin, all VXLAN-based systems need this kind of huge MTU, like Flannel. That's bigger than Flannel by a bit, though. Yeah. Okay, so what they're talking about is the MTU size and VXLAN. And I guess to give a little bit of explanation about what Sin and Duffy are talking about is the network encapsulation that we just talked about uses a protocol called VXLAN. And VXLAN is actually the standard in how you would sort of, I use the word buried, but let's just say like sneak or hide or encapsulate network packets inside of other network packets to be traversed across a broader network and then decoded on the other end later. By default, Weve uses VXLAN, so does a handful of the other CNI providers, and the MTU is a configurable metric that as you use more and more VXLAN, that usually goes up, and Duffy was just commenting on how large that metric was. Curious why it is so large myself. Let's see what Sin says. Also, for gossip-based systems, I think my old distributed system textbook says there's a portion, 0.13 of the cluster will not be reached. Interesting. So are you saying that, Sin, this is a question for you. Are you saying that by default, gossip is a lossy protocol and that we will only be able to reach the majority of the cluster? Which I think would be fine because the theory would be another peer in the gossip network would be able to reach that small portion that we can't reach with the first one. I don't know. I want to make sure I'm understanding that right. But a curious metric. If you have any more information, Sin, that would be helpful. Nadir says 13. I'm just going to read people's comments in the chat. This is great. Nadir says 1376 is for GRE tunneling. Duffy says, makes more sense. Thanks, Nadir. Thanks for pointing that out, Nadir. Did not realize we needed that for GRE tunneling. Okay. Yes. Okay. I'm going to kind of jump back in here and look at the Weve command line tool a little bit more and talk about what Weve's going to be doing while we add a node to the cluster. So to do that, we're going to hack Kubicorn, and we're just going to come over here to our ASG. Does somebody want to pick a number greater than 1, less than 10? First number I see in chat that is greater than 1 and less than 10 will win. And let's go to our node, and let's go actions, edit. And then down here, we can come in and we can do desired capacity, minimum and maximum. Nobody's picked a number yet, so I'm going to go with 7, unless somebody else types something by the time I finish entering this 7 and drinking my kombucha. Finally, Caslin picked 6. We're going to go with 6 for Caslin. Okay. The reason I wanted to do a random number is because we can change this and see how the Weve dynamic IP allocation works behind the scenes, which is helpful for auto-scaling your cluster, and it's going to be super meaningful when we look at how the cluster API is working and we start actually implementing this stuff in real time. Looks like multiple people picked 6. Sean picked 4.2, which I think is a play on 42, which was pretty funny. Thanks for doing that, Sean. I always love a good Douglas Adams quote drop. And let's go ahead and let's save our ASG with 6. And real quick, I also want to do Weve status IPAM. Okay, cool. So I got this one in. So what this is talking about is how Weve does all of its dynamic IP management based on the peers in the network. In this case, the peers are our nodes. Weve was sort of around before Kubernetes, so a lot of this existed before Kubernetes, so it's not married to a node necessarily, but in this case, that's what we're going to be referring to it as. And in this case, that's what we're going to be measuring. Sean says exactly. So yes, that was a Douglas Adams quote. Good job, Sean. Okay, so while those nodes come up, let's watch them here. Get nodes. We can watch and both see the peer list that's being generated, and we can also watch and see how the dynamic network allocation is being managed using the commands here. But more importantly than anything else, I wanted to talk about what Weve is doing to the underlying system to make all of this magic happen. Because not only is Weve using IP tables and mutating the route table that we saw with some of the other CNI implementation, but Weve is also using this really cool thing I just learned about called IP set. And I have some commands here to show some really interesting things for Weve behind the scenes. The first one that I wanted to show was this IP tables save command, which I wish I would have known about this on the previous CNI episodes. This is sort of a really great user-friendly way of looking at the IP tables list as they're configured. And if you come in here, you can sort of see that we have Weve NPC, we have Kube Firewall, and we have a lot of other Weve rules defined as well. And then we can also run this IP set. Is that installed? Nope. So let's do apt install IP set. And all IP set the command line tool does is it just gives us visibility into this memory that's already stored in the system. And it's called IP sets. And Weve uses these behind the scenes as well. So what we can do is we can do an IP set list. And we can actually see that Weve is sort of storing this meta information in hash tables called IP set, which is pretty cool. And we can actually watch how Weve mutates this by scaling our Nginx pod that we did earlier. So let's do edit deploy Nginx. Oh, dang, I said I was not gonna open up Emacs this time. But anyway, I opened up Emacs. So let's change our replica to 100. This is gonna be really good. And so now we can run this and we can grep. Let's do grep cap A. We'll do 10, why not? Actually, let's do 8. And what are we gonna grep for? Nginx. Looky here, this is exciting. So now, actually I don't even think I needed to do the cap A. Let's get rid of that. This is rad. Okay, so this is actually mapping the overlay IP address to a pod in Kubernetes, which is really cool to actually see these two metrics side by side like this. I feel like you don't really get this with some of the other CNI providers. And you're actually able to see the dynamically managed IP addressing as well as the actual like DHCP feel of how Weve is managing IP addresses for us. So we can see all these pods we just created. We're seeing they're all in various subnets, and as we get more nodes online, we're actually going to watch and be able to see how Weve status IPAM. Look at this now. Now we can actually go in and see how Weve is doing the division of IP address space across our nodes and for each of our pods, which is really cool. And we can also see Weve status. What was the other one? Trying to remember. Peers. Weve status peers. That's the one I wanted. And now we can see all these interesting rules of how the different nodes are doing this auto discovery using gossip and actually finding themselves and creating rules to talk to each other and routing behind the scenes. So interesting to see how Weve is working, and interesting to see that we're able to auto scale our cluster, and Weve is sort of doing the math and the magic behind the scenes to give us handy overlay IP addresses for our pods as we are creating them. So let's scale our Nginx deployment back down. To 1. And we can go back and run our command again, and we should be able actually to actually watch the IP sets shrink as well, because we're freeing up some of those IP addresses and therefore freeing up valuable network space on our overlay network, all without having to touch the external network, all being encapsulated with VXLAN and encrypted with, I feel like we should do like a drum roll, like how is Weve encrypting network packets with their VXLAN implementation? I have a link to this. XFRM, which is a kernel level feature that allows for encryption and an implementation into IPsec, which is pretty cool. So we're getting some encryption there as well for our encapsulated network packets as they traverse the host network. This is a really excellent write-up. It's in the Weve documentation if you want to come and learn more about XFRM and how Weve is doing the encryption, and actually some examples of some really cool IP tables you can run for actually checking this stuff out and poking around behind the scenes. And furthermore, I would not be a good open source citizen if I didn't pull up a man page at some point. You can actually interact with the XFRM kernel module using this command if it's installed on your system, and you can actually read this little snippet here, which actually talks about what this layer of software does. XFRM is an IP framework for transforming packets, such as encrypting their payloads, which is what we're doing now. This framework is used to implement the IPsec protocol suite, and with the state object operating on the security association database, the policy object operating on the security policy database. It's also used for IP payload compression protocol features of the mobile IPv6. So this is fancy network talk for we are encrypting our network packets using this really cool open source layer of software and kernel module called XFRM that of course is present on our host system because we're using Ubuntu. Justin, let's see what you have to say here. Another useful debugging tool is Weve Report, which will give you a ton of information about its understanding and state of the cluster. Let's check out Weve Report for Justin. So let's clear our screen with Control L and run a Weve report. Oh, and it's JSON. Do we have JQ installed? Oh, we do. That's handy. I love when JSON is color-coded. Like if you're going to echo JSON to the terminal, you might as well echo color-coded JSON to the terminal. Okay, so let's scroll up. This is quite wordy. I'm assuming these are from all of our pods. Mac, nickname, last seen. 10.134, 10.52, 10.156. Interesting. Let's go up to the top and see what we got here. Okay, so we overflowed our buffer again. Let's see what Justin says. One place that has been extremely useful is when we have nodes that disagree about who owns what IP blocks and have other network partitions between one another. Sean says JQ is great. Okay, so this is handy as well. I would probably, if I was a systems engineer or a SRE like I was in the olden days, I would probably be pulling this information and backing it up pretty routinely. But let's see what else the Weve command can do, just for funsies here. So we did Weve status, we did Weve report. Let's do Weve PS. This sounds pretty cool. So Weve, oh, and before we do Weve PS, actually we can do it after we do Weve PS. We're gonna scale down our cluster as well. So here, this is exciting. These are container IDs. These are MAC address of our bridge here, which I think we could, what is it, IP bridge? I think you can just do this. IP tunnel, maybe. Nope. Okay, I was going to try to actually find that MAC address for our bridge here, but it doesn't really matter. I'm just going to try to connect the dots. Anyway, we have container IDs when we run this Weve command, and we can see the address range that is associated with them. And so if we actually do like a Docker PS on one of these, or I'm sorry, a Docker inspect on one of these, you can actually go through and actually pull the Docker information on the container as well. So you can see that Weve is very much interacting with the container runtime and with Docker, and that's how we're building the pod network. And that's how we're actually effectively building our overlay network and encapsulating network packets with XFRM. So that's kind of like the round robin connecting the dots for Weve. Bogdan says, try Cuddle. Let's try Cuddle. Not to be confused with Bear Cuddle. Cuddle. Is there a bridge command? Bridge list? Bridge monitor? I don't know, if anybody wants to try or to suggest one of these, can I do Cuddle? Is there a show? Yeah, Cuddle show. Nope, not quite. Let's let's scale down our cluster really quick. Sorry, I'm zoning out here. Let's scale down our cluster really quick and then run a new Weve status IPAM and see how the dynamic allocation is being handled there, because that's going to give us a lot of information on auto-scaling our Kubernetes cluster. So how we're going to do that, go back to Amazon, go to our ASG. We're going to edit our node here, actions edit, change you back to 1. Did I do the thing again? Why does the ASG console always give me such like a hard time? Okay, so ASGs, nodes. Let's edit this thing. Change 6 to 1, change this to 1, change this to 1, hit our hidden save button over here, and we'll wait for the ASG to do its thing, Kubernetes to catch up, and then run our IPAM list again and check that out. And while we're here, we're about an hour and 15 minutes in. I got another meeting coming up, so we're getting close to the end of the episode. We'll do this one last thing where we'll, we got to talk about network policy still. So yes, Weve does implement network policy in the same way that Calico and Cilium does, so you're able to turn on network isolation, and the Weve pods do that. Remember, there was a container, Weve and Weve NPC, will actually go and implement your network policy for you. I don't think we're going to have enough time to go through the demo today and actually do the Calico demo, but I did run through it earlier in the week, and it does in fact work. It's a pretty straightforward implementation, so I don't want to spend too terribly much time dwelling on it. But if folks have any questions about how, in fact, Weve does implement network policy, I'm happy to take a look at them really quick. But we are running out of time. We've spent a lot of time looking at the Weve command line tool here today. So while we're waiting for our cluster to scale, does anybody have anything else? And if not, feel free to drop in your goodbyes. It's always been great to see you. And we'll probably spend another 3 or 4 minutes here as we wait for our cluster to scale, look at the status of IPAM, and then call it a day. Also, if anybody has any ideas for how to get the bridge MAC address, I don't want to start Googling it right now. It's been a long week. But if you have any ideas, feel free to drop them in. I'm happy to run them. Let's see what's going on with our cluster. Our connection was closed. Okay, so yeah, this is the dreaded case of the autoscale group doing first in, first out, FIFO. So let's get the name of our remaining node and SSH into that and see what's going on. So instances. Here's our node. Let's copy this and SSH into this. SSH Ubuntu at Blim. Everybody saying, Justin, Showmax, not to be confused with Emacs. Let's try this. Cuddle, Showmax. Bridge. Cuddle, what was it, list? Cuddle, oh my god, this is crazy. Show, and then we can do Cuddle, list max, and then the name of our bridge, right? What did this thing say? Bridge, Weve. Cuddle. What was Justin's suggestion? Showmax? Bridge. Weve. I thought I tried that. There we go. Okay, finally got it. Okay, let's see. Justin, thanks for that. Bogdan, Cuddle, Showmax, Weve. Roy, by the way, if you want to get egress network policies in Weve, you need 2.4. Otherwise, it only supports ingress policies. That's good to know. I didn't realize there was a discrepancy between the two, Roy. Thank you for pointing that out. Olav says, how about Weve scope for network visualization? And then Sinhan says, not list max, show max. Okay, yeah. Let me go back and do our kget nodes really quick. Okay, so we're back down to one node. And now is our Weve command line tool on here. It's not installed, so let's reinstall this thing again. So, installing Weve Net. We'll copy this. Go back here. Chmod plus x user local bin Weve status IPAM. It's going to pull our container and run it. And let's just see what our IPAM is doing now. Okay, unreachable. Oh no. And so this is, remember earlier we talked about like how the network will sort of be eventually consistent. So this is a case of it being eventually consistent here. Duffy says Weve scope is great and CNI agnostic. Thanks, Duffy. And we can probably watch as our IPAM rebuilds itself and as we slowly zero out our cluster over time. So this is an example of scaling your cluster with Weve and showing how the cluster uses gossip to do peer discovery and how our cluster behaves as we try to scale our cluster up and down. Sean Smith says, random question you might know about. Was the KubeCon CFP notification day pushed out because of the number of CFPs? Yes, I think it was. I think I was supposed to, well, actually, never mind. I'm not going to say that. Unsure, Sean, but I can find out and get back to you. I will tweet about it afterwards. I'll ping some of my people on the inside. Anything else with Weve, or should we say goodbye? I got to run to the next meeting in 9 minutes, so having a small break before my next meeting would be helpful. And as always, it's been great to see everyone here on TGI Kates. We might do another episode of CNI. I might just do a small write-up and bring that up on the next episode. I think next week we're going to be off, so no TGIK next week. We have a company offsite actually here, hold on, I'm going to do the thing. Okay, here I am. We have a company offsite in Portland that we're all going to be at, and Friday is our travel day, so everybody at Heptio will be together hanging out, and nobody will be here to do TGIK, but we will certainly be back the week after that. I am unsure if it's going to be me or Joe or Duffy or who's going to be running it. We'll keep you posted as we do every week, and let us know if you want to hear another CNI or if you're interested in something else. I've got a few ideas for some other Kubernetes tools I've been thinking about doing. So yeah, just keep us posted. Let's see, Sean says, it's not a huge deal. I just saw that it was the 18th today and I thought it was earlier, so I was like, oh, hey, it changed. Josh says, can you recommend some books or resources for learning about networking and tools? For learning about networking and tools, I don't have any good ones off the top of my head. I'm like the infrastructure girl, so let me talk to some of my networking folks and see if they have any good starting points as well. I learned about the network by mostly just messing around, and then I don't tell anybody this, but I used to be a CCNA, so I did the CCNA guidebook, and that's how I learned about everything from subnets and masking and routing and then all the different route protocols and yada 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 yada. So that's how I learned about it. I'll try to find some good books and resources, and we can add them to the repo afterwards. Roy says, bye, thanks for all the Weve info. That was super useful. Sean says, have a great week, anyone. Duffy has a suggestion called Network Warrior. It's an O'Reilly book. That sounds good. Also, there's a CNI book. I didn't realize there's a CNI book. That's probably worth a read if you're going to be doing a lot of container networking. Bogdan says, please do a series on cloud storage solutions. Secretly, that's what I want to do next, is how in the same way we did CNI, doing the storage interface. Marco says, happy Friday. Have a good weekend. I'm out. Thanks for a great episode, everyone. It's been great hanging out. I hope you all learned a lot about Weve. We'll keep you posted on what's coming next. Kazan agrees with cloud storage. Josh says the secret is revealed, but safe with us. And thanks for the CNI dives. So yeah, thanks everyone for coming out. Thanks Duffy and George. You guys are super helpful. We couldn't do this without you. You're always here and got my back whenever I'm doing this, so that's really great. And more importantly than anything else, thanks for everybody who joins in the chat and helps us out. This really wouldn't happen if it wasn't for the live interaction. So folks in the chat who have been participating today, thank you so much. It actually helps really make the episode, and we're extremely grateful for you coming and being a part of this thing as well. Okay, so without further ado, I'm really going to hang out this time. I'm really going to end the stream. It's been great hanging out with everyone. We will see you all, not next week, but the week after. I feel like I should do some sort of Kris Nova out mic drop. Okay, that was my out. See you guys.